Welcome back. This is number 11 in the series. This one I received my second Orange Pi 5 Plus, ordered from a vendor on AliExpress. System got here in 10 days. Hard to believe, but I got it pretty quick. Also, the system was a little cheaper, and it did come with a eMMC 256 gig memory. I installed it, but I'm not going to use it yet because I have to do some more research. For those of you who are interested, you can try it. I took some digital pictures with my old 14 meg Fujifilm camera. Antique, I know, but that's okay. Let's look at them. G-thumb. Now, let's see here. Yeah, one of the things when you start up G-thumb, there's a error, and then it says failed to create this screen, and it failed to load the driver for a rock chip and everything. The Orange Pi 5 Plus this is August of 2013, and system's only been out less than 6 months, so there's going to be little things where whoever's maintaining the system, there's a whole line of people that get involved on drivers and everything, so we'll come back to that. Now, I've showed you G-thumb before, but here it is with a whole bunch of pictures. I'm going to click on the first one, and it will go into this little display area here. Show me that it's one of 22. 14 megapixels means the picture is 428 by 2416 pixels. Takes up 3.4 megabytes. And I'm going to put this in a full screen mode. Over here, there's arrows pointing to the lower left, upper right. It says full screen. This is full screen mode. If I left click on this, the display goes to the full screen. For size comparison, here's an American $20 bill. I don't know if you've watched the Jack Reacher series or read any of Lee Child's books, but on American currency, all the bills are the same size, no matter if it's a 1, 2, 5, 10, 20, 50, 100. They're all the same size. Anyway, now when I move the arrow, the taskbar, control bar appears at the top. If I move the arrow and leave it stationary, that disappears. Okay, the system comes in a brown box that is slightly larger than needed, so this rattles around in the box, but it just put in a crate with everything else and comes on the boat, gets off at the LA port, gets into the US postal system, and gets to you. So it shouldn't be shaking around very much. This is the eMMC comes in this little box. Here's the power supply, and then the Orange Pi 5 Plus comes in a box that's wrapped in plastic here. If I open the little box and take out the eMMC memory module, this is what it looks like. Why did we go back? Oh, it went forward for some reason. I must have clicked something. This thing is the size of a postage stamp. It's still inside the anti-static bag, so use all kinds of caution to make sure that you don't charge up and zap something, especially if it's expensive. These things are less than 15, 16 bucks if I remember correctly. So here's the box that the Orange Pi is in. Open it up, take it out of the anti-static bag, and this is what it looks like. Again, caution on several things. One is static electricity. Number two is your cats, dogs, kids, roommates, strangers, whatever. Get everybody out of the area during this assembly process. In the center here is the Rockchip RK3588 system on a chip. Let me point out now, because we're going to put a heat sink on the top of it. The heat sink only comes in contact with this area here. So if the heat sink is slightly off center or whatever, you're okay. Important thing is to get the heat sink to cover. Why am I know what it is I hit the scroll wheel on the mouse. Sorry. Couple of things. Here are the two memory chips. These are 8 gigabytes each. This is 8 plus 8 is 16. So this is a 16 gigabyte system. If you are constrained on your budget, or you're not sure you want to invest $120 plus, you can get the low end model, which is just under $90, with 8 gigabytes. I think that's the low end. 8 gigabytes, that's plenty. Because I'm going to show you that a lot of us grew up with less than 1 megabyte of memory. This is the power module for the chip, the processor, and we've already been through all this. If you're not familiar, go back to the start of the series and work through it. This area right here is where the MMC module plugs in. These two connectors are different sizes, and see this little dashed white outline here? There's a 45-degree angle here, so the little truncated edge of the printed circuit board goes with that corner cut off on this side. First thing you do is you're going to need a case, and I recommend this 52pi.com case you saw in episode 1, where I got the one that was on Amazon. This one I got from, I think I got it from AliExpress, but I'm not sure. May have gone back to the other one that gets to your location in less than 5 days if you're in the United States of America. Open the box up and take out the case. For this one, it came in the box unassembled. That is, the screwdriver and the bag of parts is outside the case. The first one, they were inside, and the 8 screws that held the top onto the bottom were in their position, but on this one, the screws are in the bag. Open the bag, take the top off of the case, open the bag, and you've got the feet that go on the bottom. Turn this case upside down and put those on the bottom. It's not real critical. I just put them, 5 millimeters or so from the edge diagonal so that they're symmetric, but, just an OCD thing. These are the 4 heat sinks. These silver or steel screws with a Phillips head. 4 of them are used to mount the board on the in the bottom of the case. The other screw is an extra, and then these are the screws that hold down the lid on the case. If you take the heat sinks and turn them upside down, there's a thermal pad with sticky glue on the sides, and it comes with this, I think it's 1/10 of a millimeter, which is 100 micron thick plastic coat sheet on here. You want to remove this. Now, a lot of people, first time they do this, they mess this up. what you want to do is take a pin or your number 11 X-Acto knife or something and very carefully lift the plastic on one corner without touching the white thermal pad. Get this up where you can grab it with tweezers, needle nose pliers, or your fingernails and peel it off so that it looks like this. Again, when you do this, and this is why you have the cats and the kids and everybody else out of the room, anything that touches this surface is going to stick, and it's going to stick better than anything else that you've ever seen. So be extra careful here. Now what I do is I go and I place it 1 or 2 centimeters above the chip, get it centered, and then slowly, very carefully lower it, double checking all sides to make sure it's as symmetrical as you can get it centered. And then when it touches the top of the RK3588, it's in place. So gently push on the top of it to make sure that the whole area is glued down, and you're done. I can't emphasize being extra careful in doing this, that you do not have to use a whole bunch of pressure. This is not a MMA fight or anything like that. Just gently push it in place. So this is the main heatsink in place. Here are all 4. The 2 long rectangular ones go over the 2 memory chips, and then the square small one goes over the power unit for the RK3588. You'll notice these things have little imperfections in the lid and everything. I'm pretty sure that, first of all, they're extruded aluminum. They're coming off the assembly line 1,000,000 an hour. They go into a bin. They just bang against each other, so it's okay. They do their job. Anything else I need to point out here? This board is an OP5 plus, I'm going to pronounce this OP5. You can pronounce it OP5 if you've seen Oppenheimer. But anyway, OP5 plus, this is version 1.2 of the board. I didn't look at the version number of what's in Colossus. On the right-hand side here is the 40-pin GPIO, which is exactly a perfect match for the 40-pin GPIO on a Raspberry Pi system. So any hardware experiments you want to do with the shields and everything for the Raspberry Pi, you can use them. Problem's going to be, well, it's not a problem. You just have to find documentation and learn how to use the interface. Here is the MMC in place. Note the edge here matches the dashed outline in place. And this thing snaps in place. You just get it carefully aligned and push down on it gently until it snaps. And you're good to go. Here's the fan plug that the CPU controls, or some other logic in the chip controls this so that it lowers the speed of the fan when the system's not doing anything. Then when you put it in load and the temperature goes up, it speeds up the fan. But the fan in the RP50, what did I say this was, a RP52 case, doesn't have this connector. It goes into the power plug. Here is the 1 terabyte solid state drive that I used. Now the board is upside down, and for some reason I didn't take a picture of the bottom of the board, but there are plenty of it on the Orange Pi sites. The board, the M.2 form factor on this NVMe solid state drive the connector, these pins right here, go into a connector on the left-hand side here, not shown. And then on the other side of the board, there's a half moon cutout, which sits on this mounting post right here. Now this is the one problem. I got lucky the first one. On this one, I could not find a screw. A screw does not come with the case. And I've asked the people to possibly find and provide a screw with the case. That would save everybody a bunch of pain. So I MacGyvered this. I don't know if you know who MacGyver is, but I used some number 24 stranded wire, Teflon coated, but just something that's insulated. And I tried to look at the stretch cord on a surgical mask, but it's too big to fit in the hole of the mounting post. So what I did is I tied a knot in it and put it on the top side of the board, pushed the wire through, went and flipped the board over, then tied this knot, and using tweezers pushed the knot down until it was snug against the board. Now again, be very careful, because these two pads here, there's a gap between the ground plane, and these two pads here are hot. That is, they go to some electronic some part, I don't know if it's test circuit at the factory when they burn it in or whatever. So stay away from these. There is a possibility that you might have a screw that will work if you have a glass repair kit. I don't know if you've seen them. They come with a little screwdriver and a whole bunch of different size small screws. But anyway, this is the way I did it. It'll probably work without this, because when I put the board in the case, with this setup, it's still a millimeter or two away from the bottom. But if this board were to touch the bottom, this would be the thing that touched the case, and this would be insulated from it. But I can't guarantee that. You just have to set it in place and see. All right, so now I've placed the OP5 in the case with the holes here lined up with the 4 mounting posts in the bottom of the case. Here you can see a better view of the 40-pin GPIO. Here you see the HDMIs, USB 2.0s, Ethernet, RJ45 jacks. All the things are lined up with all the parts. And this case is just beautiful. Now you take your 4 steel screws and very carefully insert them in here, and then using the screwdriver, tighten them down, and you do not have to force this thing. Just snug it, which is a scientific term, or just screw down until the screw comes in contact with the printed circuit board, and then maybe twist a half a turn or a quarter turn. This thing's not going to Mars on a spaceship, I don't think, unless you're a part of that program. Maybe one of these will go in some instrument or whatever, but anyway, there's the 4 screws and everything's in place. Now you take your top cover and place the red and the black connectors to pins 4 and 6. The way these pins are numbered, this is 1, see the 1 there? This is 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes all the way down to 40. So the fan connects to these 2. Here it is from the top, kind of out of. It is absolutely out of focus, but anyway, this is pin 4, this is pin 6, there's where your fan goes on the outer row. Here's the case together with the screws in, and we're ready to go. Here's the back. Well, it's hard to say which. I would call this the back because this is where the power supply plugs in on this USB-C. Here's the 2 Ethernet. These are 2 output HDMIs, and this is input. So when you plug your monitor in, by the way, these are regular size HDMIs and not the micro size. So fortunately I had cables, but you know, you may need to consider an HDMI cable if you don't have one already, and they're cheap. Here, this is not powered up or anything. I just plugged this in to show you where the power cable does plug in. If you plug it in the front, nothing's going to happen. Well, something may happen, but it's not going to be right. This is not the configuration I have the system in. I have another USB-C power meter, which you've seen in a previous session, in place, and this one is just like Colossus, my first system, on power consumption. But let me check. I got both of them running. Oh, the problem is this one's running the video and everything. The system that you see here is plugged in, and it's only consuming 3.6 watts, sitting there not doing anything. Okay, there I go again. That's the slideshow showing how the assembly process and everything was done in detail. Let's see how much time I've consumed here. 22 minutes. Or was there anything else? So, I can't show you, but this monitor that I'm using here now has multiple ports. So, the first system, which I call Colossus, that's the one you see here, is attached to port 1. If I bring up my input here, you see the HDMI 1. When I want to go and look at the other system, I go slide down and then punch OK, and the monitor will switch. Now, because this system is recording on this screen, if I do that, nothing will show up. And anyway, the other system I named Guardian. From my notes that I've been taking along as I created as we were going along in this series, I added a new user, Adams, installed all the stuff I moved the system over to the solid state drive, rebooted on it, took the SD card out, so it's all set up just like this system. Now, the reason for having 2 systems is later on, when we get further along, I'm going to show you how how we can communicate between the 2 systems. So it's part of the Linux, Unix history. So that will do it for today, well, for this session. The next video, number 12, is going to cover why I'm excited about the use of an Orange Pi 5 Plus to do some serious research. Because you have so much compute power in just one system that you would not believe, and I'm going to try to make a believer out of you in the next video. So thank you for your time. Hope this has been educational. I'm going to note send an email to the case manufacturer and to Orange Pie to see if I can get the screw. Number two is to get Orange Pie to look at some of the missing drivers. Thank you, and appreciate your time.